Assalamualaikum. We meet again on the second subtopic for optical instrument. Today we are going to learn about magnifying glass. Magnifying glass is made up from one single converging lens. As you can see here, this is the magnifying glass. As you can see in figure here in this slide, what you will see is that this is what happened to our naked eye. If we place an object far from our eye, the angle here is smaller, and this angle will be subtended to the angle at the back of our lens. An image will form on the retina. If we move our object at near point, which is at 25 cm, and near point is the minimum distance to see object clearly. So what you will see that the angle here is larger compared to the object distance that is far away from our eyes. Okay, so angle here will be subtended at the back of our lens in our eye, and image will form on the retina. Then why we using magnifying glass? As you see in here, these two diagram, our retina has a certain area. If we place an object at our near point, we still can see object clearly. Okay, but if you move your object less than 25 cm, what you will see is that the image become blur. Why? This is happen because area on our retina cannot focus the object clearly. So that's why we use magnifying glass. Magnifying glass using converging lens, which is have small focal length. If you see here, this is the focal length of the magnifying glass or the lens here. This is where we place the object. So as you can see here, from this lens, image will form at the in front of the lens, which is a virtual image. So our eye, when we see the magnifying glass, our eye will assume the virtual image here as the actual object. Okay, so that's why we can see object become larger as we see through the magnifying glasses. Since we talk about the magnifications, so in magnifying glass, we call it as angular magnifications, denoted by capital letter M. So it can be found using this equation. M is equal to theta prime over theta. Please take alert with these two diagrams. Theta prime is the angle when we put a lens here or with lens and with lens. While theta here is angle without lens using our naked eye. So using the trigonometric function, so you can see that theta prime is equal to height object divided by distance of object here. And according to this figure, theta is equal to height object divided by the near point value, which is 25 cm. So you get here. Simplify this equation, you will get angular magnification M is equal to n over d naught, where n is the near point, which is 25 cm, and d naught is the object distance. So you can see here the equation. There are two equations, which is m is equal to n over f and m is equal to n over f plus 1. So we are going to see two situation, which is the first one is image located at infinity, and second is when image is located at near point of our eye. So image formed at infinity, according to this diagram also, we know that magnification M is equal to n over f. So using the lens equation, we are going to derive the equation for angular magnification at image, location image at infinity. So you can see here, we know that the angular magnification m is equal to theta prime over theta, or m is equal to n over d naught. Since we know the length equation is 1 over f is equal to 1 over d naught plus 1 over di. 1 over f is the focal length, d naught is the object distance, di is the image distance. You solve this equation until lastly you will get m is equal to n over f. Second situation is image formed at near point. We know that angular magnification for image at near point is n over f plus 1. So we want to prove this. So same as before, we know that angular magnification is equal to theta prime over theta is equal to n over d naught. Using length equation here, okay, rearrange all the information you know here, and then you put substitute the information into the equations of m, and then lastly you will get m is equal to n over f plus n over n, which can be simplified into n over f plus 1. So it is proof that image at near point, the equation is equal to m is equal to n over f plus 1. Let us see exercise 2.21. Okay, exercise 1a. What is the maximum magnification given by the lens, and what is the magnification for relaxed eye viewing? Okay, from this question, what I can take out is that I know that the focal length of the lens is equal to 12 cm, and I know that near point value is equal to 25 cm. First question asked is what is the max magnification? Max magnifications mean that the image is located at near point. Okay, so m is equal to n over f plus 1. Substitute all the value, you will get is equal to 3.08 x. X is represent magnification. 3.08 magnification times magnification. For question B, relaxed eye view means that the object are placed, the image are placed at infinity. So this is the equation. Substitute all the information, so you will get 2.08 x. Same goes with this exercise 2.22. So take out from question. So I know the f, I know the n, and then substitute according to the question. What question 1? So I will get 3.5x, and question B, I'll get 2.5x. That's all for magnifying glass. So stay tuned. We are going to meet on the second subtopic, which is cameras and projector. Thank you.